Hi, in this video, I'm going to walk through all the ways in which Dataiku integrates with Snowflake and also build an end-to-end demo of a data science project using Dataiku and Snowflake. First off, what is Dataiku? Dataiku is a universal AI platform that lets enterprises connect to their data wherever it lives, use whatever compute they would like, and also connect to a variety of foundational large language models. In Dataiku, we have low-code and full-code tools that enable anyone from an ML engineer to a data analyst to be able to clean up data, build analytics workflows, train traditional machine learning models, incorporate Gen AI into their pipelines, and then also deploy and monitor and use CI/CD best practices with all of these assets. Now, as it relates to Snowflake, this just means that anyone in an organization, people who can code, people who can't code, can use the same Dataiku UI to leverage Snowflake data and compute behind the scenes. So including SQL warehouses, Cortex large language models, Snowpark Python, and even Snowpark container services. In this demo, I'm going to pretend that we work for a bank, and we're going to redefine their loan default prediction process with AI using Dataiku and Snowflake. So we're going to connect to Snowflake, clean and join data using no-code tools, engineer features with Snowpark Python and Modin, train an ML model using no-code tools using Snowpark ML, make batch predictions, also deploy this model for real-time predictions in Snowpark container services. Then we're going to use a large language model through Snowflake Cortex to offer applicants a custom loan. Then we're going to use an LLM to create a beautiful PowerPoint summarizing trends in our data. And then we're going to monitor joint Dataiku Snowflake usage with the Optimizer native app. So we have a lot to cover. First off, connecting to Snowflake. This is the Dataiku UI, and an administrator can connect to a Snowflake instance and database warehouse role schema. We can also add in variables here to make them kind of dynamic. We can connect using OAuth or user password. And you can also pass in a cloud object storage connection like S3, which will make loading and unloading data to and from Snowflake super speedy with their copy into command. Then you can give access to the Snowflake connection to different groups in Dataiku. Then we can make a connection to Snowflake Cortex large language models by pointing to that earlier connection, and then just check off any of the models you want to make available to users, including any custom models for stuff that you're adding. We can also add PII detection, toxicity detection, and a few other layers around these Cortex LLMs. All right, so once we've established our connections to Snowflake, let's work on a project. In this project here, I have some customer information already in a Snowflake table, and I've already done a couple data cleaning steps to it. Let's bring in another table from Snowflake. So I'm going to browse a data collection. So someone at my company has curated some data for the finance team here. So I want to use this loan requests table. All right, and now it's in our project. Before we do anything, I want to quick mandatory puppy. There are a lot of Easter eggs in Dataiku. And now let's clean up this table using our prepare recipe. And we're going to store the output table also in Snowflake. Okay, so here we're going to add steps to the script here on the left. So we're going to replace months with nothing to make this column a clean integer. Next, if I want to deal with some of these misspellings of the word mortgage, I can cluster some similar values together. And let's just change a few of them. Let's see if this captures all of them. This looks a lot better. Let's say we want to split this FICO range column on that dash. I can search my processors, and you can see we have about 109 different tools for cleaning your data. Let's split the range on that dash to pull out the first and second number. And then we can use our formula to add the first to the second and divide by 2, right? So we're just getting the midpoint of this FICO range. Cool. So this all looks good. I think my data is pretty clean now. So I can click Run. Up until now, we're just operating on a sample of our data set, but clicking the Run button will actually push down a SQL query to our Snowflake warehouse to run all of these steps on my entire table, no matter how large it is. Cool. Let's now join these two tables together using our join recipe. And let's rename the output data set loan requests joined. Dataiku will try and guess the join conditions. We can always change them here, including the join type. Again, I'm going to click the Run button to push the query down to Snowflake. We can view the query here. You can even convert this to a code SQL recipe if you want to change this query manually. All right, so you can see Snowflake is really quick with running these operations. Now let's say I want to use Python code to do some feature engineering. I can create a Python recipe, and let's call the output data set loan requests features. And Dataiku will automatically generate some code to read in our input table, transform it into a pandas data frame, and then write that pandas data frame, whatever you want to do with it, out to the output Snowflake table. We have some code samples for doing the same thing with Snowpark code. So taking our input table and turning it into a Snowpark data frame. And then same thing, writing a Snowpark data frame out to a Dataiku table. So this way all the compute happens in Snowflake and Snowpark. All right, so let's edit this in a Jupyter notebook. And I want to select a Python environment here. And I'm going to select Py39 Snowpark Modin. In Dataiku, you can manage different virtual Python code environments and R environments, and install whatever packages you want. So we've installed the packages you need to use Snowpark Python and Modin for Snowpark Pandas. All right, and then conveniently, like a cooking show, I've already written up some code here. So this just imports some different libraries, including Snowpark and Modin, so that we can do things like instantiate a Snowpark session, point to our input table, get a Snowpark data frame, and also convert that to a Snowpark Pandas data frame using Modin. So here we can see we have our Modin data frame. All right, once you're done kind of testing out the code of this recipe, we can save it back into our Python recipe here, and then run this. So this way our Python node is a part of our larger workflow, along with our visual recipes. All right, great. So you can see here we just used some Snowpark to apply a UDF to divide a column by 2 and created a new column there. But this can be whatever Snowpark code you want, or Snowpark Pandas, or any other Python package. All right, next thing I want to do is split our data into loans, known, and loans, unknown. And here I want to send loan applications where the defaulted column is defined to the loans known data set, and all other records will get sent to loans unknown. And this is basically splitting our data into the loan applications where I know the default status. I'm going to use those applications to train my model. And then I'm going to use that trained model to make predictions for the unknown loan applications. So these are just loan applications where we don't know if they're going to pay them back or not. They're just sitting in my inbox for the moment. Okay. Before we train a model, I just want to pull open a quick statistics chart. And let's automatically suggest some analyses. So it's always a good idea to try and understand relationships in your data so that we can choose features wisely to include in our model. So we can take a look at different distributions of our numeric features and also something like a correlation matrix. So here we can see the defaulted column. It looks like interest rates and the FICO scores seem to matter a lot. So we'll be sure to include those in our trained models. All right, speaking of training models, let's take our trained data set and use the Visual Snowpark ML tool. And we're going to create an output train data set, an output test data set, and a folder to store our models. All right, in this interface, we can train a number of machine learning models to predict whatever we want in our data set. And this will use Snowpark ML behind the scenes. So we can name our models loans, snow, demo. And we want to predict this defaulted column. This is a two-class classification problem. I'm going to split my training data set into 80% train, 20% eval. Let's optimize our models for ROC AUC. And then let's choose a number of input features to include in our model. So these are going to be super important. Our model is only as smart as these input features are predictive. Okay, let's include age seems good. Let's for sure do interest rate. Maybe state as well. And let's do monthly income too. Okay. Now we can choose some different algorithms. So these are different ways to predict our target variable. So let's turn on these three. And when we set the search space to 4, this will choose 4 hyperparameter combinations in this feature space for each of these models. So this will train 3 times 4, 12 models. And let's use a medium Snowpark warehouse to get some extra memory to train these models. And let's deploy our best trained model to the Snowflake ML model registry. All right, so I'm going to kick off this model training process, and we will see what comes out of it. All right, cool. So it looks like this training job succeeded using Snowpark ML. We can check out how this experiment went here. So we can see all the different models that we trained, along with their model metrics, the algorithm type, and their hyperparameters that were chosen in the grid search space. And we can see even more about the best trained model, which was deployed to the Dataiku flow. And here we can see some cool stuff like feature importances. So here we can see that the model considered FICO scores, interest rates, and the amount requested to be the top features, which makes sense to me. And if we look at low FICO scores, those tend to have a higher probability of default, which also makes sense to me. Whereas higher interest rates have a higher probability of default. We can see a confusion matrix here. So we can see that of the 58 applicants who defaulted in the test set, our model correctly flagged 56 of them, but at the expense of missing out on the business of 123 applicants. So we can also toggle this threshold around if you want to make the model more sensitive or less sensitive, depending on what kind of bank you are. All right, so now we can take this model and make predictions on our unknown loan applications. Cool. So now we have a table in Snowflake with all of our loans where we don't know if they are going to default yet, but our model has returned to us a prediction that we can use to determine should we give this person a loan or not. So this is batch inference. Now, if you want to deploy your model for real-time inference, so let's say you have some sort of point system where you want to send in the features of an applicant and receive back a prediction immediately, we can create an API service. So test API, predict default. And we can push this to the Dataiku deployer. And then we can deploy this to Snowpark container services. So from the admin setup side, all a Dataiku administrator needs to do is create a compute pool on the Snowflake side, a registry and image repository, and then enter those in here. And then you'll be able to deploy any of these machine learning models or other API services to Snowpark container services. So we have a service that I've already deployed here. You can see it's green, it's looking good. We create a public endpoint URL, and you can add some authentication on top of that if you'd like. And then you can access this endpoint either through SnowSQL, leveraging a UDF that we create behind the scenes, or using Snowpark Python, where we're connecting to Snowflake so you can authenticate. Here, pass in your Snowflake token, pass in a query with some features, and then hit that model and retrieve back a response. So what you can do with this is have something like a web app, which we link to our model on Snowpark container services, and then we can change the inputs and see in real time some of the changes in the model's predictions. You can see these numbers changing a little bit here. All right, cool. So that's for real-time scoring. Going back to batch inference, I have all these loan applicants. Now let's say I want to email the loan applicants where I've determined that they're likely to pay back this loan, right? So let's maybe filter it down to just loans, predict payback. And let's filter on that prediction column. Or sorry, 0.0. We want the people who are going to pay back the loan. So you can see it's pretty easy to change these recipes and then rerun them. Cool. So now we just have the loan applicants where our model predicts that they're going to pay back the loan. All right, now let's open up a prompt studio. And let's call it generate loan app email. And let's just do a blank template here. And now we're going to choose one of our Snowflake Cortex large language models. So let's start out with Mixtral 8x7b. And I want to just ask the model to write me an email offering a loan. Please be friendly. And then I can choose that input data set. So here we want to choose that loans predict payback data set. And then I want to pass into this LLM some features about my applicant, including the amount they requested. So I'm going to reference that amount requested column. And I'm going to do the same with a bunch of columns here, like the loan length, the FICO score, and the interest rate. Cool, and this will pull tests, like 8 example test records, and we can test out how this Snowflake Cortex LLM will perform at this task of writing emails offering these people loans. Okay, cool. So this is nice because it's customized. You can see that the FICO score we're injecting into the email, the amount requested into the email. It says we've reviewed your loan application. We're pleased to offer you a loan. Blah blah blah. So it's nice and custom. This is like a good customer experience here. If you wanted to try out a different Snowflake Cortex model, you can do that also here and see if that one would perform better. But this one looks pretty good, so I'm going to export it as a recipe. And then run this. So now we're applying the same prompt and inputs and LLM to our entire input table on Snowflake of all of our applicants where we've accepted their loan. So this is going to generate a ton of emails en masse. So this combo is a really nice way to leverage LLMs just as another part of your pipeline. Okay, cool. And then I should mention that Dataiku has all of these other LLM recipes for creating vector stores, summarizing text, classifying text, fine-tuning LLMs, and even evaluating LLMs. I'm not going to go into it in this demo, but there are lots of other no-code ways to leverage LLMs in Dataiku, even creating agents in Dataiku. Okay, cool. Let's now take what we've built in this pipeline and let's create a deck summarizing some of our findings for executives. All right, so next I can go back to my workspace, my finance workspace here, and I can use any table or other object in Dataiku and deploy it to this workspace. And I can create a story, let's call it Snow Demo, and point this story to a Snowflake table that we created downstream. And now we can create a PowerPoint that's connecting to the Snowflake data, which is live Snowflake data here. And we can even use GenAI to automatically create this presentation. Let's see what it comes up with. Okay, so we have a nice intro slide. And here the large language model is able to automatically generate charts that are backed by this data in Snowflake. So here we can see average default rates by the loan purpose. And it'll even create some cool graphics here. And let's say you want to change this up a little bit. We can ask AI to, for example, please make the colors in red palette. I don't know if I'm spelling palette correctly there. Okay, cool. So it did change it to red. So you can edit these slides however you want, but it's nice that we can use GenAI to create the base. All right. want to take a peek back at our project. So our prompt recipe finished. So now we can see for all of these loans where we used a traditional machine learning model to predict whether or not they'd pay it back, and then used Gen AI to generate an email, right? We can see we've got some nice tailored emails for all of these loan applicants, which is really nice. Then we can use a Dataiku scenario to automate all of this stuff. So in Dataiku, we can add triggers, so something like a time trigger. So every, let's say, week, on Monday at 4:20 a.m., let's go ahead and, for example, run some quality checks on a key data set in our flow. We can also rebuild a downstream element of our flow. So that can be one of our training data sets. We can also retrain our model. And we can automate so many other things, including updating our real-time API deployment on Snowpark Container Services. Then we can add a reporter to report back to our team via email, Slack, or Microsoft Teams, the output of the scenario and even scenario data. Finally, with all of these joint integrations between Dataiku and Snowflake, I also want to show you that Dataiku has a native application called Dataiku Snowflake Optimizer, available for free on the Snowflake Marketplace. And this lets our joint customers easily track and optimize your usage of Dataiku and Snowflake together. So it's pretty easy to install this app. Once you do, you'll be able to monitor things like Dataiku recipes, warehouse compute, and Snowflake Cortex LLM queries, all of the integrations that I showed you earlier. All right. Thanks very much for watching this video on Dataiku and Snowflake.